So today we are looking at matrices. Matrix is applied in many fields. It's a quantitative topic, actually in mathematics. It is applied in, you can see matrix in economics, that is high level of economics. You can also see matrix in finance, particularly quantitative methods and other levels of finance. But we will look at it from the SHS angle and then you link it to the economics and the finance level. So we are going to look at the general things that one should know under matrices. So general knowledge. And the matrix. So basically what we are supposed to know is maybe we will look at addition and subtraction of matrices. We will look at multiplication of matrices. First we will look at the dimension of a matrix. So addition and subtraction of a matrix, we look at multiplication. We'll look at inverse, or before inverse, we will look at determinants of a matrix. Look at determinant of a matrix. We look at the inverse of a matrix. But I'll look at determinants and adjoints. Adjoints basically for 2 by 2 matrix. So when I say 2 by 2, you will understand. So these are the general knowledge one has to get under matrix. When you are able to get these things, the rest you are good to go. Yes, you are good to go. So we take it one by one. So let me write the things. When we do it, then I'll take it. So dimension. So let's say DMI, then addition and subtraction of a matrix. Matrices. We look at multiplication of matrices. We look at determinants or debts, and we look at adjoints. We look at inverse of a matrix. All these are applied in economics, finance, and other courses, maybe in physics and other courses that you have. So we will start with the dimension of a matrix. Matrix is mostly, many a time we see a matrix of this form, we mostly hear A, B, C, D. You can also have A, B, C, D, E, F, G, H, I. Now when we look at this one, we have in spreadsheets or in ICT, we have something called rows and columns. So with this, these are called the columns. And if I have something like this, the horizontals are called the rows. So we have this as a row and this as a column. So likewise in matrix we have rows and we have columns. So when I say I can have this, so this one become a column, this one become a row. So we look at the number of columns here will be what? 1 and what? 2. The number of rows here will be what? 1 and 2. How about this one? The number of columns here will be 1, 2 and what? 3. 1, 2 and 3. The number of rows will be 1, 2 and what? And 3. So with this one we can say this is a 2 by 2. Now to know the dimension of a matrix, we have row by column. That's how we name the dimension of a matrix. So number of rows by the number of columns. So this is a 2 by 2 matrix. Where this will be what? A 3 by 3 matrix. We can have a 2 by 1. We can have a 3 by 2. So example of a 2 by 1 may be like, okay, I have, and mostly it's like a 2 by 1 is something like a vector form. So if I have AB, now I have one column one column. The rows will be what? 2. So 1 and then what? 2. And if I say 3 by 2, I mean like, okay, A, B, C, D, E, F. This gives me 3 rows. How many columns? 2 columns. So that is 3 by what? 2. So that's what we call dimension, or how to know the dimension of a matrix. The number of rows by the number of columns. So that's how we call, or we identify the matrix dimension. As we go forward, when we look at the multiplication, there are tricks to the dimension, what to get, what not to get. Yes. So we look at that. So we can be writing as we go through. I'll go straight to the addition and subtraction of matrices. So assume A, that is the matrix A, is A, B, C, and D. And matrix B is equal to E, F, G, and H. Then I tell you to add or subtract. So for addition and subtraction. Now what we have here, each, this can be written as matrix A11. So the A11 signifies first row, first column. Then A12 will be first row, second column. This will be the second row, right? So it will be second row, first column. And this will be second row, second column. So every matrix has entries. The A11, A12, A21, A22. So this can also be like B11, B2, B12, B21, B22. So look at this. The B11 here is the E. The B12 here is the F. The B21 is the G. The B22 is the H. So when we have A plus B of a matrix A plus matrix B, we add or subtract the corresponding entries. What I mean by corresponding entries is that we pick, if it's about adding or subtracting A and B, you pick the entry A11 corresponds to B11, A12 corresponds to B12, A21 corresponds to B21, and A22 corresponds to what? B22. So we can have something like, I'm going to just use the entries. So it means that the A11 will add or, so for plus or minus B11, comma, then A12 will also take the words B12, comma, then we come to the second row. The A21 will take the B21, and the A22 will take the B22. So for instance, with the A, B, C, D, the E, F, G, H, the A plus B will be A plus or minus B. Now I'll take the A, then I'll take that of E. A plus or minus E. And I'll take, when I come to the second column of the first row, it is B here, so B plus or minus, then I'll take that of the B. Here it is F. Then I'll come to the second row. So C plus minus G, comma, D plus or minus H. So that becomes my A plus or minus B. So that is A plus or minus matrix B. We will solve by numbers, then we understand better. So we are done with this, and we are doing this. Okay, so I'll clean it, and then we go by examples. Then so illustration. Given that matrix A, or say mat A, matrix A is equal to 2, 4, 3, 5, and matrix B is equal to 5, 6, 8, 7. Find I. A plus B. I. A minus B. That's what we are going to do. So, solution. 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 So, we'll take A plus B. So we are giving, so A plus B becomes 2, 4, 3, 5 plus, so we are solving step by step. 5, 6, what? 8, 7. So we do entry by entry. So now this becomes the 2 will take the what? The 5. The 4 will take the 6. The 3 will take the 8. The 5 will take the 7. So you have 2 plus 5, comma, 4 plus 6, then you have 3 plus 8, and then 5 plus 7. Okay. Then we come down. 2 plus 5 gives me 7. 4 plus 6 gives me 10. 3 plus 8 gives me 11. And 5 plus 7 gives me 12. So this becomes my A plus B. So I've solved for A plus B of the matrix. So then we have A minus B. A minus B. A minus B will be 2, 4, 3, 5 minus 5, 6, 8, 7. So we take entry by entry. So the 2 will take the 5. So 2 minus 5, 4 minus 6. 3 minus 8, 5 minus 7. Then you are going to get 2 minus 5 gives me negative 3. We have 2 oranges, but you owe 5 oranges. So the 2 oranges that we have, rules can be used to pay only 2 of them, then you still be owing 3. So negative 3. So 4 minus 6 gives me negative 2. Then 3 minus 8 gives me negative 5. Then 5 minus 2 gives me what? 5 minus 7 gives me negative 2. So this becomes my A minus B. So if you are in SHS and you have any textbook, you can try and solve more questions for the addition of a matrix. Then we are going to look at the multiplication of a matrix. So I'll close this, or let me say clean it. Not close. I'll clean this, then we'll look at multiplication. And this is for 2 by 2. Likewise, you have 3 by 3. It's all about the entries. So the first entry, okay, let's take example of a 3 by 3 addition and subtraction. So we are going to look at 3 by 3 addition and subtraction. So given that matrix A is equal to 2, 3, 4, 5, 6, 8, 7, 9, 1. And matrix B is equal to 1, 2, 3, 5, 6, 4, 8, 7, 9. Find, this one I'll only do only one. I'll just do the addition, then the subtraction we can. To find A plus B. Solution. A plus B becomes 2, 3, 4, 5, 6, 8, 7, 9, 1 plus 1, 2, 3, 5, 6, 4, 8, 7, and 9. So when I'm adding, this will add to this, this will add to this, this will add to this. You have to know the corresponding entries. So I'll have 2 plus 1, comma, then I'll take the second one, 3 plus 2, comma, then 4 plus 3. And I'll come to the second rule, 5 plus 5, comma, 6 plus 6, then 8 plus 4. Then the last rule will be 7 plus 8, 9 plus 7, and 1 plus 9. This results in 2 plus 1 gives me 3, 3 plus 2 gives me 5, 4 plus 3 gives me 7, 5 plus 5 is 10, 6 plus 6 is 12, 8 plus 8 is 16, 7 plus 8 is 15, 9 plus 7 is 16, and 1 plus 1 plus 9 is 10. So, we are done with the addition of 3 by 3. Done with the addition of 3 by 3. So you can try with the subtraction. And try the subtraction. So we are going to go to the multiplication of numbers. Now we also look at multiplication of a matrix. So, I left one thing. We'll also look at identity of a matrix. Let me do that one first. So, for every matrix can have identity. So in binary operation, you have something called identity element, whereby any number operated on the identity elements, you get back the number itself. And when a number is operated on its inverse, you get the identity element. That is in binary operations. So in matrix 2, you have identity matrix. So for 2 by 2 matrix, the identity matrix, so identity matrix for 2 by 2, I is the diagonals will be 1, then the rest other inputs will be 0. So you have 1, 0, 0, and 1. So this diagonal is what? 1. So for 3 by 3 matrix, the identity is 1, 0, 0, 0, 1, 0, 0, 0, 1. So that becomes the identity matrix for 2 by 2 and for 3 by 3. Can go on and on, 4 by 4. If you want to do 100 by 100 matrix, but I've not seen 100 by 100 matrix before. Maybe in machines can calculate 100 by 100, but with manual calculations or with questions that students are mostly asked is basically the 2 by 2, 3 by 3 maybe. The highest may be like 4 by 4. And that may be in terms of mathematics, linear algebra, or modern algebra, where you may be applying the echelon formula. So this echelon formula. So let's now go to multiplication of matrices. So we are going to look at multiplication of matrices.